is an essential control experiment. We do lead-lead in order to study the medium effects, the effects which are due to the deconfined medium that we produced in lead-lead collisions. We have proton-proton, which is a very important control experiment, because there we at least do not expect any medium to be produced. But we could have effects that we see in lead-lead, which are just due to the fact of using lead as a projectile instead than proton. And for instance, initial state effects, which have to do with the initial distribution of the colliding particles inside the lead nucleus as opposed to a proton. And to check this type of effects, proton lead is an indispensable control experiment. And that is why we are very excited about this run, which is just about to start. And we have had already an appetizer in September, in the night between the 12th and the 13th of September. During a machine pilot run, we had a few hours of stable beams, so we managed to collect a couple of million events, so not much in terms of statistics, but already we have been able to extract some quite good physics out of that. We have measured the multiplicity of particles which are produced in proton-lead collisions, and its dependence on the pseudo-rapidity within the central barrel of Alice. And this already is putting stress on some of the particle production models. For instance, the change of the multiplicity with pseudo-rapidity is less steep when going from the proton hemisphere to the lead hemisphere than is predicted by saturation models which are on the market. A very important measurement was the nuclear modification factor. So we have measured how the particle production changes as a function of transverse momentum going from proton-proton to proton-lead. And this we did for unidentified charged particles for the moment. And what we see is that when we go above a transverse momentum of 3 GeV or so, the nuclear modification factor is 1. So there is no modification of particle production with respect to proton-proton, and this indicates that the effects that we see in lead-lead, the strong suppression that we see in lead-lead, is a medium effect. Of course, to finalize this, we will need to look at this as a function of the particle type, protons, pions, kaons, etc. And we have made this very puzzling observation, studying two-particle correlation, that this ridge in pseudo-rapidity, which was first observed by CMS, is actually a double ridge. So there is one at 180 degrees, there is a second ridge accompanying it, and the two ridges have a magnitude that increases together, so they are very well correlated, which suggests a common origin for the two. We don't know what this origin is at the moment, but there are possible interpretations. There are papers already out invoking saturation effects, color-glass condensate, or even hydrodynamic expansion. And of course, it will be very important to determine what this is. And for this, we will need the new data. This is just one of the many reasons we are very excited about the new run. We will need to measure the production of heavy flavors. We will need to measure the production of gypsy, the production of jets. And for all of these, we will have the baseline measurement against which we have to calibrate the lead measurements, and there is, of course, some genuine proton-lead physics to be made as well. And there may well be other surprises there.